Pokemon! It's
Hi everyone! Today we'll explore one of the core concepts in calculus derivatives. Derivatives measure the rate of change of a function with respect to a variable. It simply tells us how fast something is changing. Now imagine Pikachu running. We don't just want to know how far Pikachu has gone, we want to know how fast Pikachu is moving right now. That's exactly what a derivative tells us the instantaneous rate of change. In other words, it's the slope of the curve at that very moment. To calculate derivatives, we use some basic rules. My friends are here to introduce each one. Let's start with constant rule.
In constant rule, if f of x equals c, then f prime of x is equals to 0, where a constant is an element of any real numbers. For example, if f of x is equals to 1, then the f prime of x is equals to 0.
Just like what he said, the constant rule says the derivative of any constant is 0. For example, if f of x is equals to 7, then f prime of x is equal to 0. Constants don't change, so their slope
Next is
is
identity
0.
rule. If f of x is equals to x, then f prime of x is equals to 1. For example, if f of x is equals to 2x, then f prime of x is equals to 2. Another example is the derivative of 24x is equals to 24.
So he said the identity rule says the derivative of x is 1. So if f of x is equals to 19x, then f prime of x is equals to 19 times 1. And 19 times 1 is equals to 19. So our final answer is f prime of x is equals to 19. So the slope of a straight line with slope 1 is always 1. Now let's move on to the next rule.
So in this lesson, we're gonna find the constant multiple rule for derivatives. It's c multiplied by f of x is equals to c times f prime of x. Then here we have a problem. It's 3x to the raised of power of 5. So we're gonna take the constant here. This is the constant 3. Then the function is x raised to the power of 5. So we're gonna take the constant here. Then 5x to the raised of power of 5 minus 1. Then we're gonna rewrite this here. It's 3 5x to the raised of power of 4. And we have our final answer here. We're gonna multiply this 5 in here. So we're gonna have the 15 to the raised of power of 4.
The constant multiple rule says if you multiply a function by a constant, the constant just comes along when you take the derivative. For example, if f of x is equals to 7x cubed, then f prime of x is equals to 7 times 3x squared, which is the derivative of x cubed. Then 7 times 3x squared is equals to 21x squared. Now, let's move on to the power rule, which we use here in constant multiple rule.
This lesson, we're gonna use the power rule. It's f of x equals to x raised to n. Then f prime of x is equals to n times x raised to n minus 1. Then here we have a problem. It's f of x is equals to x cubed. And here we have f prime of x is equals to 3x cubed minus 1. We're just gonna bring the 3 in the front. Then we're gonna negative 1 here. Then here we have our final answer. It's 3x cubed.
So, in power rule, it says that the derivative of x raised to n is n times x raised to n minus 1. So, for example, if f of x is equals to x raised to 4, then f prime of x is equals to 4x cubed. Now, let's move on to the next rule.
In some rule, if f of x is equals to f of x plus g of x, then f prime of x is equals to f prime of x plus g prime of x. Now, for the first example, we have 12x squared plus 2x squared. And
2x.
first, we're gonna find the derivative of 12x squared plus 2x. And the derivative of 12x squared is which is 24, and the derivative of 2x is 2. Then 24 plus 2 is equals to 26, and that's the final answer.
So, in sum rule, the derivative of a sum is just the sum of their derivatives. So, for example, if f of x is equals to x squared plus 3x, then f prime of x is equals to 2x plus 3, because the derivative of x squared is 2x and the derivative of 3x is 3. Now, let's move on to the next rule.
In difference rule, if f of x equals to f of x minus g of x, then f prime of x equals to f prime of x minus g prime of x. And for the example, we have 6x cubed minus 4x. And first, we're gonna find the derivative of 6x cubed minus 4x. And the derivative of the 6x cubed is 18x squared. And the derivative of 4x is 4. Since we cannot combine like terms, and this is the final answer.
In difference rule, the derivative of a difference is just the difference of the derivatives. If f of x is equals to x cubed minus x, then f prime of x is equals to 3x squared minus 1. Now, let's move on to the next rule.
In product rule, if y equals to f of x times g of x, then y prime equals to f prime of x times g of x plus f of x times g prime of x. For example, we have y equals to x squared times x cubed, f of x equals to x cubed, and the derivative of x squared is equals to 2x. And g of x equals to x cubed, and the derivative of x cubed is equals to 3x squared. And for the y, and next is we're gonna find the y prime equals to equals to 2x times x squared plus 8x squared times 3x squared. And we're gonna do the following operation, which is 2x squared times x squared, which is 2x raised to 4, and plus x squared times 3x squared, which is 3x raised to 4. And next, we're gonna combine like terms, which is 2x raised to 4 plus 3x raised to 4 is equals to y prime equals to 5x raised to 4. And that's the final answer.
In product rule, the derivative of a product is first times derivative of the second plus second times the derivative of the first. For example, y is equals to 2x times x squared. So, y prime is equals to 2x times the derivative of x squared, which is 2x, plus x squared times the derivative of 2x, which is 2. So y prime is equals to 2x times 2x plus x squared times 2. Then do the following operations. 2x times 2x is equals to 4x plus x squared times 2 is equals to 2x squared. Then combine like terms. So 4x squared plus 2x squared is equals to 6x squared. So our final answer is y prime is equals to 6x squared. Now, let's move on to the next rule.
In quotient rule, if f of x equals high over low, then f prime of x is low multiplied by the derivative of high minus high multiplied by the derivative of low all over low squared. For example, we're going to find the derivative of x all over x squared plus 1. First, we're going to find the low and high. For the low equals x squared plus 1. And the derivative of low is 2x equals to 2x. And next is high. High equals x. The derivative of high is equals to 1. Next, we're gonna plug in the values. X squared plus 1 times 1 minus x times 2x all over x squared plus 1 quantity squared. Then, we're gonna do all the following operations. X squared plus 1 times 1 equals to x squared plus 1. Then, x times 2x equals to 2x squared all over x squared plus 1 quantity squared. Then, next we're gonna do the other following operations. X squared plus 1 minus 2x squared is equals to negative x squared plus 1 all over x squared plus 1 quantity squared.
In quotient rule, the derivative of a quotient is low times the derivative of high minus high times the derivative of low over low squared. For example, we have y is equals to x squared all over x plus 1. Our high here is x squared and our low is x plus 1. Now let's find the derivative of y. So y prime is equals to x plus 1 times 2x, which is the derivative of high, minus x squared times 1, which is the derivative of low, all over x plus 1 quantity squared. Now let's do the following operations. X plus 1 times 2x is 2x squared plus 2x minus x squared times 1 is equals to x squared all over x plus 1 quantity squared. After that, we're gonna combine like terms. So 2x squared minus x squared is equals to x squared plus 2x all over x plus 1 quantity squared. Since it cannot be further simplified, then our final answer for y prime, or the derivative of x squared over x plus 1, is x squared plus 2x all over x plus 1 quantity squared. Now, let's move on to the next and last rule.
In this lesson, we're gonna talk about chain rule. And the first thing we're gonna do is find the formula. The formula is f g of x equals to f prime of g of x times g prime of x. We're gonna have an example here. It's 5x plus 3 raised to the fourth power. We're just gonna bring the 4 to the front, then subtract 1 from the 4. It's 4 minus 1 is 3. And we're gonna keep the inside the same. Then we're gonna find the derivative of the inside. It's 5x plus 3. It's just 5. Then we're gonna multiply the 5 to the 4 in the front. It's gonna be 20. So our final answer is 20, and keep the inside the same. It's 5x plus 3 raised to the third power. This is our final answer.
In chain rule, it says that the derivative of the outside is multiplied by the derivative of the inside function. For example, we have f of x is equals to the quantity of x squared plus 1 quantity raised to 5. Here, our inside function is x squared plus 1. Let's make our inside function with the variable u. So, u is equals to x squared plus 1, and the derivative of u is equals to 2x. Now, first, we're gonna find the derivative of the outside function, which is u raised to 5. So, the derivative of u raised to 5 is 5 times u raised to 4. After we find the derivative of the outside function, we're gonna find the derivative of the inside function. So, the derivative of our inside function is 2x. After that, we're gonna plug in the values. So, f prime of x is equals to 5 multiplied by the quantity of x squared plus 1 quantity raised to 4 multiplied by 2x. After that, we're gonna multiply 5 by 2x. So 2x times 5 is equals to 10x. So our final answer is f prime of x is equals to 10x multiplied by the quantity of x squared plus 1 quantity raised to 4. And that's the last of the basic rules of derivatives. Now let's have a recall. So, derivatives measure the rate of change of a function with respect to a variable. And we have the basic rules of derivative, which is constant rule, identity rule, constant multiple rule, power rule, sum and difference rule, product rule, quotient rule, and the chain rule. Now that we learned the basic rules of derivatives, let's check your comprehension. Alright, that's it for today's lesson on the rules of derivatives. I hope this makes solving derivatives much easier for you. If you found this helpful, don't forget to like and share. Thanks for watching, and always keep learning.